and no mammals or reptiles would ever have emerged. And there would be no humans telling the story of life. After this first mass extinction and the ones to come, life branched out into billions of different forms, each family, each group, each species being part of a vast spreading tree.
There's always winners in the lottery of extinction. And whatever those survivors are, that's where the next radiation happens. That's where the next evolutionary burst happens. So if you want a simple way to think about extinctions on planet Earth is the survivors are the winners and their descendants are the ones that populate the next time period.
The desolation of a mass extinction sets the stage for an evolutionary renaissance. Within tens of millions of years of the Ordovician catastrophe, the survivors had given rise to a new era, the Devonian. It was a completely new world, full of new prey and new predators. Some quite astounding.
In the sea, we call it the age of fishes because now the fishes have evolved and they're diversifying and you get some whoppers. And one of the greatest fishes of all time is this animal called Dunkleosteus.
Dunkleosteus is the super predator of the age of fish, right at the top of the food chain. It probably swam in a constant search for large enough meals, even specimens of its own kind. In the Natural History Museum in Paris, a plaster cast of Dunkleosteus's impressive jaw testifies to the killing power of this giant of the Devonian. This is the well-honed weapon of a fearsome hunter. Paleontologist Gail Clément studies placoderms, the large family to which Dunkleosteus belongs.
This animal is part of the group called placoderms, which means that they have thick bony plates under their skin. Here we see the jaw, with these sharp points which are not teeth, because teeth didn't exist yet. It's actually the jawbone, which presents this pincer form, so it can crush and chop up the prey on which it fed.
And while Dunkleosteus terrorized the seas, the continents were being transformed.
The beginning of it on land, they're little tiny things, and by the end there were forests. The Devonian is when you get a land environment that starts to look like something you might recognize. You go from nothing to forests.
But trees release water vapor into the air and may have triggered epic storms over the continents. Torrents swept dead and decomposing plant matter into the oceans, choking them. Oxygen levels plummeted. Global cooling and volcanic turbulence may have worsened the crisis in the seas as well. For marine life, sustenance grew scarce. Eventually, the food chain collapsed. The Devonian extinction strangled 3/4 of the world's marine life to death. But on land, the forests kept thriving. Any creature looking to survive the disaster at sea would have to seek greener pastures, literally, and that would require some anatomical innovation.
So you have a variety of fish that actually are maneuvering their way around in shallow water, and they have these lobe-like fins that actually, if you look at the fossils of them, they actually, you can start to see the rays of the fins actually have distinct bones. And it's this lineage of fish that eventually evolves into amphibians.
With the seas suffocating and the lush land beckoning, the menu required updating. Pioneering fish like Tiktaalik, a descendant of the bony fish that slipped through the first mass extinction, had already been experimenting with life where the shallows meet the land. It had gills to breathe in water, but also a primitive lung for breathing air, and 4 robust fins that would later become legs. Fleeing the choking oceans, Tiktaalik and its family, the Sarcopterygians, crept out of the water and slithered through the second great extinction. And the world would never be the same. A new chapter in the history of life began. And again, in the race of life, the winners give rise to new branches of the evolutionary tree. In the new age of the Permian, the first modern trees developed. Photosynthesis enriched the air with oxygen. At the same time, the continents drifted together to form a supercontinent, Pangaea, a vast new territory for land-going animals to explore and exploit. Animals unlike anything the world had ever seen before evolved to handle life on terra firma, where conditions like temperature varied much more wildly and harshly than in the seas. To protect their offspring, big predators like the Gorgonopsians began to lay the first eggs with hard shells. All the early land animals walked on 4 legs, hence the name tetrapods, a body plan that's as revolutionary as any in the story of life. And some were quite flamboyant.
What you've got are animals that look like a big iguana with a great big sail on its back. It's likely that these sails were for either impressing the other sex or for moderating heat. You can rotate towards the sun and your blood is warmed up on this big warming surface. Or you can rotate away from the sun, you can cool it down.
These pelycosaurs with their iconic sails lived alongside Dicynodonts, herbivores with a new innovation, a beak designed to excavate the tough roots on which they fed. These huge animals were probably hunted by the biggest predators in Pangaea, like the Titanophonius or Titanic killer, a reptile that could grow to a length of 5 meters. In the seas, 100 million years after the collapse of the oceans, vibrant new lifescapes flourished.
You would have just loved scuba diving in the Permian. And you've got all these incredible creatures that are out swimming around, There's corals, there's cephalopods. The fishes have gotten big now, and you've got your first sharks. Certainly one of the most amazing is this animal called helicoprion. It basically had this whirl of teeth mounted in its lower jaw, and it would slam into its upper jaw, and it was a slicing mechanism. It swam around in the sea and just chopped stuff in half, and then came back and ate it.
The massive fossilized teeth from this buzzsaw shark suggest it could have grown to a length of 12 meters. On land and in the water, the biodiversity of the Permian was simply spectacular. But it was doomed. The most devastating natural catastrophe the Earth has ever seen so far awaited them. A cataclysm that would transform this paradise into hell on Earth for millions of years. Some 250 million years ago, in what is now Siberia, the Earth tried to turn itself inside out. These vast cliffs, called traps, formed when the planet belched lava over and over again for tens of thousands of years. Iceland, one of the most volcanically active countries in the world, is entirely built by lava flows. It is an open-air laboratory for geologists like Patrick de Wever, and embedded in the rock, he finds the barrels of a lava flow's smoking guns.
When there's an emission of lava, there are holes in the mass of rock, and these holes are filled with gases, which come out at the same time as the magma. There are different types of gas. There's water vapor, there are sulfur oxides, and carbon dioxide. We know water vapor is a greenhouse gas which tends to raise the temperature, as does carbon dioxide. But sulfur oxides have a double effect. On the one hand, they cause acid rain and they also partially block out sunlight, leading to a drop in temperature and lower light levels, which means a reduction in photosynthesis and so perhaps fewer plants. And since animals feed on plants, fewer plants mean herbivores start to die, and then, in turn, the carnivorous animals die too.
The Permian Triassic extinction was the mother of all extinctions. Basically, a lot of our friends that have been with us for the entire Paleozoic, things like trilobites, the last trilobite goes. Lots of these earlier marine organisms, they've survived through much of the earlier extinctions. Sorry, can't make it through.
On the other side of the world, in China's Zhejiang province, researchers Sylvie Crasquin and Marie-Beatrice Forel are in search of one creature that survived the Permian disaster in the seas, hoping to find the secrets of how to cheat extinction. Here, at the dividing line between the abundant Permian and the disaster-ravaged time just after, the researchers locate what they're looking for. Tiny crustaceans called ostracods.
Je pense qu'on voit des choses qui pourraient être des ostracodes, Marie.
Ah bon?
Ostracods had an ability to adapt to some of the most stressed environments in the history of the planet. In her Paris laboratory, Sylvie puts her prizes under the microscope. Ostracods from before the disaster are pretty large for miniature marine life. The ones from immediately after are not.
Juste après la crise, les conditions vont être extrêmement stressantes.
Just after the crisis, conditions were extremely harsh. You can imagine that ostracods went into energy-saving mode, meaning they reduced the metabolism as far as possible to consume less energy, which is why you find smaller ones, which also had smaller eggs, and with reproduction cycles that are much shorter than those usually observed in the Paleozoic.
On observe en général dans le Paléozoïque.
After the devastation of the Permian, life hit the reset button once again. On land, the few tetrapods that survived, descendants of the first land-going vertebrates, would evolve into reptiles, dinosaurs, and mammals. Millions of years later, by the start of the Triassic, the branches of the tree of life are once again blossoming.
The Triassic is a time of tremendous innovation because the decks have been cleared so severely in the Permian Triassic. So you basically wipe the slate not clean, but pretty clean. The Triassic is this really crazy place where these things now radiate again into all these different kinds of shapes and forms. Lots of really cool, weird animals in the Triassic.
In the ocean, marine reptiles had emerged, like the ichthyosaurs, which roamed the seas hunting fish and squid. Corals bloomed and built reefs once again. Ammonites proliferated, along with sea urchins and starfish. In the skies above, the first flying reptiles, called pterosaurs, beat their huge wings. On land, great herbivores with tough leathery armor grazed in conifer forests. Their defensive carapace hints at the presence of fearsome predators, like the agile Coelophysis, which probably hunted in packs. The two-legged 40-pound Coelophysis was one of the first dinosaurs to grace the Earth. It would take tens of millions of years and another global catastrophe before giant dinosaurs completely dominated the world. Some 200 million years ago, Europe and Africa tore away from the American continent, forming the Atlantic Ocean. The Earth entered a new period of volcanic upheaval. It set in motion the fourth mass extinction in the planet's history, wiping out 3/4 of land-dwelling species and 96% of ocean species. The great Permian experiment lay in ruins. But once again, life would rise like a phoenix from the ashes.
The dinosaurs survive. the mammals survive, the pterosaurs survive. So on land, you have these lineages now that are often racing.